Good morning. Let us see some examples in the following program segment. I, j, m and n are the integer variables. The values of m and n are supplied by user in the execution of the program. Suppose the loop is for I equals to 1 to m, for j equals to 1 to n. If I not equal to j, then print I plus j. So how many times the print statement is executed if m equals to n equals to 10, m equals to 20, n equals to 20, m equals to 10, n is equal to 20, and m is equal to 20, n is equal to 10. So let us see the general formula. So here the number of times the print statement executed. So here you can observe that the condition is I not equal to j. So first case we will say if m is equal to n. So first what happens here is I is fixed to 1 and j is equal to 1 to n. Here in this case m is equal to n. So first time when I is 1, j is equal to 1. So only in that case it will not be executed. Let's rest all n minus 1 times the loop gets executed for the first time. Second case when I is equal to 2, then again there are n minus 1 cases where the I is not equal to j. So therefore the number of times this loop gets executed is n minus 1 times m, or it is m minus 1 times n. This is because only when m is equal to n. Suppose the case is when m is less than n. So that is here m is less than n. So in that case the number of times the loop gets executed. First time I is 1 and j is varies from 1 to n. So therefore it is again n minus 1 times. So this will be done for m times. So m into n minus 1 times the loop gets executed. Next, that is a printf statement get executed. Next is when m is greater than n. So when m is greater than n, then what happens is until m is equal to n, this executes for n into m minus 1 time. So then for the remaining m minus n times, this condition will be true for n times. So it is plus m minus n times n. The loop gets executed after m is becomes greater than the value of n. So therefore in each of the case substituting the value of m and n in the general formula, we are going to get the required answer. So the first and second case are the case where m is equal to n, and the second case is m is less than n, and the third case is m is greater than n. So substitute in the required formula and get the output. Next is here. So when you can, if the applications of this is you can use this and or operation for representing the circuit, digital circuit. So this is a circuit diagram for the P. That is, you have two terminals and between you have P. Now this is a parallel connection. So where one is P and another is Q, but they are tied between T1 and T2. Parallel connection, it is representing P. The expression for parallel connection will be P or Q, because the current can go either from T1 to T2 through P or from Q. Next is T1 and T2. Between that you have series connection P followed by Q. So first to travel from T1 to T2, it requires to travel from P first followed by Q. So the expression is T and Q. So now for the circuit diagram, write the circuit diagram for the following expression. So we will take up one and then the remaining you can do it. So now here you have to observe this is and, the outer expression is and. So it will be this my T1. This is first expression and second expression and third expression. This is my T2. And means it is series. And now this one in first expression is OR. So it is series connection P or Q or R. This is connected in series. This is the first AND expression. Next is again you have three which are connected in parallel. So first is P, second is T, and third is negation of Q. Next is again you have three expressions which are connected in parallel. P minus T, that is negation of T, then R. This is the whole circuit diagram for the first expression. So likewise for the remaining two you can draw the circuit diagram. Next, coming to the remaining rules of inference. So here the rule of conjunctive simplification. So here you have been given a compound expression P and Q. So this P and Q is true when P is true, Q is true. Therefore I can say that both P and Q must be true. So therefore I can write P is true, Q is true. Next is rule of disjunctive amplification. So when P is true, so if I or with any Q or S or anything, so I will get the true expression. Therefore P, it implies P or Q. Next is rule of conditional proof. Whenever P and Q is true, as well as P implies Q implies R is true, therefore R is true. So why? Because here P and Q is there, which implies P is true, Q is true. So P is true means P is 1 and Q is also 1. So whenever this implication is true, P is true, this Q implies R must be true. And this Q implies R must be true, which again we have Q is 1, therefore R must also be 1. So therefore we come to the conclusion that R is true. Next is rule for proof by cases. If P implies R and Q implies R, therefore P or Q implies R. Because here when P implication R is true, then P may be true and R may be true. So all the cases arise excluding P is 1 and R is 0. Next again Q is implies R, therefore P or Q implies R. This will be true. Next is a rule for constructive dilemma. So P implies Q, R implies S, P or R, therefore Q or S. That means here you have P implies Q and R implies S. Therefore, if you are the left hand side of the two implication, that is P or R is true, then Q or S must be true. This you can again verify by the truth table also. Next is rule of destructive dilemma. So P implies Q is true, R implies S is true, and negation of R or negation of S is true, then negation of P or negation of R is true. It is just the opposite of the constructive dilemma. In the constructive dilemma, we have considered P or R, that is the left hand side, or is true, then the right hand side R is true. Whereas in the destructive dilemma, we consider the negation of the right hand side R is true or of the right hand side negation. Therefore, the negation of the left hand side with OR operator is true. And make a note here. This upward arrow indicates the NAND operator. So A NAND B is equivalent to negation of A and B, which is nothing but by applying the De Morgan's law, negation of A or negation of B. Then downward arrow represents the NOR operator. A NOR B is the negation of OR. negation of A or B, which implies which is equivalent to negation of A and negation of B. So now you might have studied in FCST, that is using NAND and NOR, how can you realize the basic gates. That's why these NAND and NOR are called as the universal gates. So now the question may be arising saying using NAND represent A and B, using NAND represent or using NAND represent the NOT, using NOR represent the basic gates NAND and OR and NOT. So likewise questions may also arise. So you should be able to write those expressions. Thank you. We'll stop here and thank you.